hour for 1 hour and moves with 100 kilometers per hour in next 1 hour. So your time interval is same. Time interval is same, 1 hour each. In such case, average speed shortcut is given by this formula. V average is equal to V1 plus V2 upon 2. You can use this shortcut. Right. Next is for projectile motion I have written. Sixth formula is for equation of the path of projectile. Y is equal to x times tan theta minus g upon 2 u square cos square theta the whole into x square. Seventh formula is for time of flight. Eighth one is for maximum height and ninth one is for range. Students, tell me with yes or no, are you able to recollect these formulas? Time of flight, maximum height, range. Yes, very good. 10th formula is a formula to calculate maximum range. I hope we remember that maximum range is obtained at 45 degrees and the value of Rmax is u square by g. And there is a beautiful relation between Rmax and capital H, and the relationship is that maximum range is 4 times of vertical height. What is the relationship? Maximum range is 4 times of vertical height. Then of course we do remember that time of ascent will be equal to time of descent. And then there is a topic of conical pendulum in circular motion. Students, whenever you come across questions based on conical pendulum, make sure to remember this triangle. Look at this triangle. In this triangle, capital H is vertical height. Theta is called as semi-vertical angle. What is theta called as? It is called as semi-vertical angle. Right, it is called as semi-vertical angle. And R is radius and L is length of the string. Based on that, students, we have written 3 formula. First one is for time period of conical pendulum, then time period of simple pendulum. I hope you remember this formula from SHM also. Time period of simple pendulum, 2 pi root of L by G. Then linear speed of the bob, root of Rg tan theta, and then the formula to calculate tension, mg upon cos theta. Formula to calculate tension, mg upon cos theta. Right, this much part is clear. For the last time, those students who are joining late, students, whatever test you have attempted, diagnostic test just before this session, that we are going to discuss, whatever doubts you all have, we are going to discuss towards the end of this session, because Vidyalankar has already provided detailed solutions to you all. So whatever minor doubts you all have, we'll discuss it towards the end of this lecture. In today's lecture, my complete focus is to solve the tutorial sheet with in-depth concepts. So what I have done is, initially, as you can see, I have written a synopsis kind of a thing where I have mentioned all the important formula, which I feel that generally students tend to forget. I have not written all the formulas that are there with you all. This is just a revision. And with that being said, let us move on to Newton's laws of motion, the second chapter in this session. So the basic formula for force we know is change in momentum over time. There is a formula for pseudo force as well. Here students, please remember the second formula, that magnitude of pseudo force is given by mass of the object into acceleration of the frame. Once again, what is pseudo force on the object given by? Pseudo force acting on any object is given by mass of that object into acceleration of the frame. Then here we have written work done by variable force. When the force is variable, you have to make use of calculus approach, which is integration. So integral of fx dx plus integral of fy dy plus integral of fz dz, and the limits are nothing but coordinates xa to xb, ya to yb, and ZA to ZB respectively. Fourth formula is for coefficient of restitution during collisions. Coefficient of restitution during collisions. And here we have written V1 vector and V2 vector formula. Students, what is V1 vector and V2 vector? V1 vector is nothing but final velocity after collision. Okay, final velocity after collision, that is V1 vector. And as you can see, the formula consists of E in it. It consists of E. So this formula we have written for inelastic collision. This formula we have written for inelastic collision. Is that clear? This formula we have written for inelastic collision. Now you will ask, sir, what happens when the value of E is 1? When the value of E becomes 1, it is for elastic collision. When the value of E becomes 1, it is for elastic collision. So this is for final velocity of the first object after collision, and this is for final velocity of the second object after collision. Right, I'm able to see some students are asking me to explain this part, second part. Students, let's have an example over here. Suppose we are having a triangular wedge like this with us, right? And there is a block placed on this wedge. Can you see this block? Block is placed on the wedge. Now I'm saying that this wedge is accelerating towards left with acceleration A. Then can we say that for this block, this wedge is behaving like a frame? Yes or no? For this block, the triangular structure is behaving like a frame. Then the pseudo force acting on the block will be in the opposite direction, and that pseudo force is given by mass of the block into acceleration of the frame. That is what I meant by the second formula. Right, that was easy to understand. I'm going to erase this. Moving on to sixth formula. Remember students, whenever couple is acting on an object, net force will always be 0. Whenever couple is acting on the object, net force will always be 0. And here I have written center of mass for few standard objects. Center of mass formula for few standard objects. Now all these objects are given in your prescribed syllabus. So I have taken only these formulas. There are other objects as well, but according to the CET syllabus, only these objects are important, and that is what I have taken into consideration. Right. After that, moving on to the third chapter, that is gravitation. Students, according to Kepler's second law of gravitation, aerial velocity is constant. According to Kepler's second law of gravitation, aerial velocity is constant. And aerial velocity is given by delta A upon delta T, which can be derived and written as L upon 2m. Students, what is L? L is angular momentum. What is L? L is angular momentum. So from second law, we can conclude that angular momentum is constant. After that, we have written the formula for GH. GH is given by the formula Gm upon R square. And there is alternate formula for GH, which is G 1 minus 2H by R. Now there might be a confusion that students, which formula is to be used when? Remember that use this formula, all right? Use this second formula for GH when the value of height is less than or equal to 320 kilometers. Only then you have to use this formula. Okay, sir, What happens if the value of height is greater than 320? Suppose 500 kilometers, 1000 kilometers above the Earth's surface. Then you have to make use of gh is equal to gm upon r plus h the whole square. After that, fourth one is for gravitation potential. The formula is minus of gm upon r plus h. Therefore, remember that maximum value of gravitation potential is 0 at infinity. Students, one mark question can definitely be asked that what is the maximum value of gravitation potential? Maximum value of gravitation potential is 0. Maximum value is 0. And where it found? It is found at infinity. Maximum value of gravitational potential is 0 at infinity. So at all other places, the value of gravitation potential will go on reducing. Do you see a negative sign in the formula, beta? Do you see a negative sign in the formula? So at all other places, gravitation potential will be negative. And only at infinity, it will be 0. Remember this. And last formula is for remaining velocity. Last formula is for remaining velocity. Students, this fifth formula you will not find in majority of the books. Whatever books you are referring to, this fifth formula, you will not find it anywhere. Now, what is this formula? Students, let's take an example. We are having an earth, object is placed on it, and we throw the object, we project the object with 3 times escape velocity. Okay, we are throwing the object with 3 times escape velocity. Then definitely they can ask you that where this object will reach. Your answer is, if we are throwing the object with 3 times the escape velocity, the object will escape. It means it will reach to infinity. The object is going to escape, which means it is going to reach to infinity. Right. Now, if the object reaches to infinity, what will be the velocity, remaining velocity at infinity? Then the answer for this is remaining velocity is given by root of 3 times VE square minus VE square, which is 2 root 2 times VE. So when the object reaches infinity, dear students, what is the remaining velocity of the object? 2 root 2 times of escape velocity. Understood this? Right? Yes, students, if you use second formula, if you use this formula for h greater than 320 kilometers, your answer will come wrong. Your answer will come wrong. Why? Because when we were deriving this formula, we have used binomial expansion, where we have neglected third term onwards expansion. So I'm not going into the details of derivation. I want you all to remember this condition. Tell me, students, with a simple yes or a no, will you be able to remember the condition for the formula? Right. Students, I have taken lots of efforts to prepare this particular formula list and also the PDF. See, what I have done is I have solved all the 71 questions with detailed solution. I have solved each and every solution, because if I don't solve, then we will not be able to complete all the questions. Along with that, I have created few animations as well. Few interesting diagrams I have created few animations so that the question will be easily interpreted. So it has taken a lot of time. I just want you all to relax. Yes, we are going to cover all the questions today, beta. I just want you all to relax and understand everything. Everything I want you to understand. With that being said, students, now what you can do is you can take a screenshot of this formula list. Be quick. Take a screenshot. Jay, the questions, the tutorial sheet questions are already solved, already given to you all. Those who are using a laptop or a computer, and if you don't know, there is a print screen option on your keyboard. You can just click that print screen, go on to Microsoft Word and press Ctrl V. Yes. So you'll be able to take the screenshot, or you can use snipping tool. Fine. Students, I hope that till now this screenshot will be taken. I'm going to proceed further. Yes, take a screenshot of this, beta. Take a screenshot of this. Taken. Students, sufficient time was given to take a screenshot. I'm going to scroll now. Yes, you can take a screenshot of this part, students. Take a screenshot of this part. Right. And now till MCQs you can copy, like take a screenshot rather. Krisan, solutions of evaluation test. I am not sure whether you will receive it immediately or not. But for the test that you appeared for, a diagnostic test, that will be given to you all by now. Okay, students, are you all done taking a screenshot till here? Fine. Now it is time to understand all the MCQs. Coming to the first question. Now, students, there is a request from my end that when I am reading the question, you will also read the question. When I'm reading the question, you will also read the question. Okay, Shreya is asking us which formula to use if they are asking to calculate height. Students, if they are asking to calculate h, it means h is unknown, correct? Then always go with this formula. Always go with this formula. Right. Okay. Talking about MCQs. Students, did I make myself clear that when I'm reading the questions, I want you to read the questions as well. I want you to open the PDF and read the questions as well. Come on, let's start. First question. A vehicle moving with 15 kilometers per hour comes to rest by covering 5-meter distance by applying brakes. If the same vehicle moves at 45 kilometers per hour, then by applying brakes, it will come to rest by covering a distance of. So students, in this question, vehicle is coming to rest in both the cases, correct beta? Vehicle is coming to rest in both the cases. Initially, also it is coming to rest. Finally, also it is coming to rest. So we can start by writing the formula. V square is U square plus 2AS. Then since it is coming to rest, v is 0. And we are using this formula because acceleration is constant. Kinematical equations can be used when acceleration is constant, right? So when you solve this, you will get u square being proportional to distance, correct? When you substitute v as 0, you will get u square proportional to distance on rearranging. Now students, read the question again. Initially the speed is 15 kilometers per hour, and then the speed becomes 45 kilometers per hour. So can I say that value of u becomes 3 times? U becomes 3 times, correct? Now if u becomes 3 times, s is proportional to u square. So 3 square is 9. So your distance will become 9 times. Your distance will become 9 times. So 9 into 5 is 45, and the answer is option C. The answer to this question is option C. Right. Let us move on to second question. A moving body is covering distances which are proportional to square of the time. Then acceleration of the body is. So here it is saying that s is proportional to t square. So students, when we convert proportionality to equality, we always multiply a constant k. We always multiply a constant k. Now the question is asking us to calculate acceleration. Do you remember that when we find double derivative of displacement with respect to time, double derivative, we will get acceleration. So we will have to differentiate displacement 2 times. We will have to differentiate displacement 2 times. So one time when you find derivative, you will get v. Then s, k is written as it is, and derivative of t square is 2t. And in order to get acceleration, find derivative one more time. So when you find derivative one more time, k is a constant, remains as it is. 2 is a constant, remains as it is. And derivative of t with respect to time is 1. With respect to time is 1. Is that clear, everyone? So this was the second question. Yes, Om. Later on, I will write the velocities for pure rolling. Not right now. Okay, later on, remind me, I will write it for you. We differentiated 2 times because from S-T relation, displacement time relation, the question was asking us to calculate acceleration. That's why there was a necessity to find derivatives 2 times. Coming to the third question. Now students, for the third question, I have created one animation. So first let us read the question and then we will have a look at the animation. First let's read the question. A body is just revolved in a vertical circle of radius r. When the body is at the highest point at h is equal to 2r, the string breaks. The horizontal distance covered by the body after string breaks is. Okay. Students, I am going to share my entire screen so that I can show you all animation. There will be a brief blackout. Yes, students, now I'm going to show you all the animation. Have a look at this. Students, can you see? Particle is moving in a vertical circle. Is it visible? Particle is moving in vertical circle, and at the highest point, the string breaks. So did you observe that when the string breaks, particle is going to follow a parabolic path? Did you see? Once again, let's have a look at the situation once again. It breaks at the highest point. particle follows a parabolic path and we have to find the value of x. Is this clear to you all? Okay. So this was easy to understand. Now I'm going to show you all how the solution works. So look at the solution beta. At the highest point in vertical circle, I hope you remember that the velocity is root rg. At the highest point in vertical circle, the velocity is root rg. After that, the vertical height is 2r given to us. And we have to find this distance from O to P. Students, can I say the distance from O to P, this distance can be considered as x, yes or no? This distance can be considered as x. So we have to calculate the value of x. Now this, if it looks more complicated, I have drawn a simpler diagram here also. I have tried to give you the solution in simplest way possible. So this is the easiest diagram to understand. At the highest point, particle has a velocity root rg. It follows a parabolic trajectory to reach this point P, and the distance of O to P is x, which we have to calculate. Distance from O to P is x, which we have to calculate. Now, once we have understood the diagram, what we can do is we can understand the solution in two parts. One is by taking all the horizontal vectors, and the other is by taking all the vertical vectors. So when we take horizontal vectors, in horizontal direction, we can simply use the formula speed is equal to distance upon time. Speed is root rg, distance is x, and time is t. Time is t. And when we talk about vertical vectors, that is vectors along y-axis, we can use the formula s is equal to ut plus half at square. Now, u is initial velocity, and dear students, initial velocity is 0 because particle has just horizontal velocity initially. Particle just has horizontal velocity initially. So vertical value of velocity is 0. Right. So u becomes 0. Then we get s, which is vertical distance as 2r, that I have substituted. Vertical distance as 2r. One second. Yeah, here it is. Vertical distance is 2r. And acceleration is because of gravity. And when you solve, you will get time. Now this is written as equation 1. This is written as equation 2. Students, substitute equation 2, that is time, over here in the first equation. Substitute. When you substitute and when you rearrange, you will definitely get the answer for x as 2r. 2r means the answer is option C. The answer is option C. So I'm sure that animation helped you all to understand that how the question is really working. What does cutting at the highest point mean? And after cutting, since it was revolving, the motion is going to be a parabolic path. Let us move on to the fourth question now. Let us read fourth question. Everybody read fourth question. A particle is moving along the circular path of radius r and velocity v. The magnitude of average acceleration after half revolution. Students, average acceleration is given by the formula change in velocity upon time. So after half a revolution, can we say time will be equal to half the time period? After half revolution, time will be equal to half the time period. And change in velocity is given by or written as final velocity minus initial velocity. Change in velocity is written as final velocity minus initial velocity, both in vector form. Now answer this. Are you able to see that direction of final velocity and initial velocity will be opposite tangents? Are you able to see that? After half a revolution, are you able to see, everyone, that it is going to be opposite tangents after half revolution? Yes. Therefore, if this V is positive, then the other V will be negative because the directions are opposite. So because of that, we get the answer of change in velocity vector as 2V. We get magnitude as 2V. Now substitute both of them in this equation. So we get 2V upon T by 2, which makes it 4V upon T. Now after we got this 4V upon T, after we got this, I hope you also remember that V is R times of omega. V is R times of omega. So this is R and this is omega. And omega is 2 pi by T. From there we can replace T as 2 pi R by V. 2 pi R by V. And when you substitute that in the above formula, above equation, on solving, you will get the answer as 2V square upon pi R, which is answer option C. Avnish did not understand. Avnish, it's a basic diagram. By now, you should be able to visualize how things are working. Look, students, can we say that suppose the particle starts its motion from this point P, and after half a revolution in anti-clockwise direction, it reaches Q, correct? Then what will be the direction of velocity at point P? It will be tangential. And direction of velocity at point Q, tangential. Both the arrows are in the opposite direction. Both the arrows are in the opposite direction. Right. So we get the answer as option C. Coming to the fifth question, students. The question says, two particles are performing uniform circular motion about a center of two concentric circles of radii R1 and R2. The two particles at the center of circle lie on a straight line during the motion. The ratio of angular velocities will be. Now students, can you see that we have taken two concentric circles and the particles, green color particle and blue color particle, both the particles are lying along a straight line. Can you see that? Now it is quite obvious that if they are going to always move along a straight line, it means that time period should be constant, na beta? If they are always going to move along a straight line, then time period should be constant. This is looking like seconds hand of a clock. It looks like, it resembles seconds hand of a clock. Now if time period is constant, it means omega is also constant. It means the ratio is 1:1. And the answer is option D. Ratio is 1:1 and the answer is option D. Very easy to understand. That brings us to sixth question. A particle is moving in uniform circular motion with speed v and radius r. How much is the angular acceleration? Dear students, since angular acceleration alpha is asked, I hope you also remember that alpha in UCM is 0. Alpha in UCM is 0 because omega is constant. So alpha is 0. If alpha is 0, directly you can mark the answer as second option. That brings us to the seventh question. A stone of mass 3 kg at one end of a 2 meter long string is whirled in a horizontal circle. The string makes an angle of 45 degrees with the vertical. Then the centripetal force is equal to. Students, are you able to understand that string is making 45 degrees of semi-vertical angle? It means that this question belongs to conical pendulum. This question belongs to conical pendulum. So we will have to recall all the formula that we have used in conical pendulum. But right now we have to find centripetal force. Centripetal force is mv square upon r. And just 10 minutes back, I told you that velocity in conical pendulum is root of r g tan theta. Velocity in conical pendulum is root of r g tan theta. There is a square. So root and square, after eliminating both of them, we get mg into tan theta. And when you substitute the values, you will get the answer as second option. Answer as second option. And students, unfortunately, the answer for this question given in the tutorial sheet is wrong. The final answer given in the tutorial sheet is wrong. So the correct answer is second option, B. Okay. Yes, Karthik, you can solve with that method also. You will get the same answer, but it will be a lengthy method. You will get the same answer, but it will be a lengthy method. This is the most efficient method of solving, where centripetal force is mv square upon r. So the answer is second option. Now students, we come to end of first page. We come to end of the first page. Don't worry, final answer key is not given, no problem. That's okay. It will be given later on, don't worry. So students, now you can just take a screenshot from MCQs onwards. Since we have come to an end of the first page, take a screenshot. Come on, everyone. Students, it took me a lot of time to write these detailed solutions with proper handwriting and color and everything, and to create the animations and the diagrams that you are going to see later on. So make sure that you are making complete utilization of today's session. Yes, Kshitij. If you are solving tutorial sheet prior to the lecture, it is always advisable. Yes. Very good, Kshitij. You can verify the answers with me now. Students, I'm going to scroll down. I hope you have completed taking the screenshot. Yes or no? Scrolling down. Take a screenshot of this part, beta. Take a screenshot of this part. Students, I would like to make a request here that all the questions that you all have, that how much time should be given per question, is CET difficulty level of CET at par G, all those questions not pertaining to today's session, all those general questions I will be taking up later on. Right now, whatever work is given to us, let us complete that. And right now, you have to take the screenshot. And if it is done, please let me know that you are done taking the screenshot. I will answer all your queries, but this is not the right time. You can ask me towards the end. Okay, scrolling down. Yeah, take a screenshot of this part. Take a screenshot of this part. Students, now we are going to start solving question 8 onwards. Second page of the tutorial sheet, we are going to start. I will start by reading the question and you will also read the question along with me. Second page, question number 8. Let's start. A body of mass m is moving along a circle of radius r with linear speed v. Now, to change the linear speed to v upon 2 and to move it along the circle of radius 4r, required change in the centripetal force of the body is. We have to find change in centripetal force of the body. So we can start by writing the basic formula that centripetal force is mv square over r. So we can say that m is a constant. So F is proportional to V square by R. Now students, look at the question and tell me what is happening to velocity. Can we say velocity is becoming V by 2? It means velocity is becoming half. If velocity becomes half, then this becomes half square because there is a V square in the numerator. And radius becomes 4 times. But radius is in the denominator. So this becomes 4 times in the denominator, that is 1 by 4. It means that our answer, new answer for force, will become 1 by 16 times. New force will become 1 by 16 times. We can say F new becomes F by 16. But the question is clearly asking you all to find the change of the force, change. So we can say that for change, we can write it like this. F new is equal to F minus 15F by 16. And the answer to this question is going to be option A. It decreases because there is a negative sign. Can you see a negative sign here, beta? Negative sign. Negative sign means it decreases. And it decreases by a value of 15 by 16. So the answer to this question is option A. Right. Let us move on to 9th question now. A string of length L is fixed at one end and carries a mass m at the other end. The mass is revolving in a horizontal circle, making theta as the semi-vertical angle of cone. Dear students, semi-vertical angle of cone means that it is conical pendulum. The question is based on conical pendulum, right? What do we need to find? If 1 upon pi revolutions per second are taking place, what is the tension in the string? So we can start by writing a fact that frequency is given to us as 1 upon pi. Since frequency is reciprocal of period, can we say time period will be pi seconds, beta? Time period will be pi seconds. Now use the formula to calculate time period of conical pendulum. It is 2 pi under the root of L by G cos theta. Substitute the values. So on substitution, pi and pi cancels out. Pi and pi cancels out. And when you square it, beta, when you square it, after squaring, this 2 becomes 4. 2 becomes 4. And square root sign is eliminated. Square root sign is eliminated because we are squaring it. The square root is neglected. It vanishes. And now what we do is, to this entire equation, this entire cloud, we multiply m. We multiply m to this entire cloud. So it becomes mg is equal to 4 ml cos theta. And do you remember that mg upon cos theta is tension? In today's lecture only, look at this formula, beta. Tension is mg upon cos theta. We have revised this in today's formula itself, today's lecture itself. So we can write mg upon cos theta, which is tension, as 4 ml. 4 ml. The answer is third option. The answer is third option. We multiplied with m so that we can find tension beta. In the formula for tension, mass is coming. That's why. That brings us to the 10th question, students. 10th question. At any instant, the magnitude of centripetal force is given by. Students, this is just a formality based question because this is the formula and the answer is fourth option. Direct formula this is. mv omega. mv omega, direct formula. Right? Okay, let us move on to 11th question. Let us move on to 11th question. Person aiming to reach the exactly opposite of the bank of a stream is swimming with a speed of 0.5 meters per second at an angle of 120 degrees with the flow of water. The speed of water in the stream is. The speed of water in the stream is. Now students, let's understand this. I'm going to re-explain it over here. See, this is your river bank. Right? This is your river bank. We are going to assume that water is going to flow in this direction from left to right. Water is going to flow in this direction, left to right. There is this person, okay? And students, this person wants to reach exactly on the opposite side. That means the person wants to reach from P to Q. Person wants to reach from P to Q. So students, can I say that if the person tries swimming in this direction, then because of velocity of water, person will drift away from Q. Correct, beta? Person will drift away from Q. So definitely we understand a fact that person should not swim in this direction. And the person should swim in this particular direction. Then one component of the velocity will be vertical and one component will be towards the left. Correct, beta? Now our aim is that person should reach Q. Person should reach Q. So this component of velocity should be equal to velocity of water. This component of velocity should be equal to velocity of water. Only then the person can travel along PQ, beta. Achha, think the other way around. Think the other way around. Tell me, students, if velocity of the swimmer in this direction is large, is more, becomes greater. If it becomes greater than the velocity of water, then can we say the swimmer is going to drift towards left, beta? Resultant will be towards the left. Simple vector concept this is. Simple vector. I think if velocity of water is more, okay, if velocity of water is more as compared to this horizontal value, then the person will drift towards right. But now think, beta, if both the values are exactly equal, If both the values are exactly equal, then this and this will cancel out each other and the person will just move along PQ. And that is our aim. That is our aim. So this is exactly what I have written here very neatly. Look beta. This is 0.5 meters per second. And this angle is given to us as 120 degrees. So the other angle is 60 degrees, simple geometry. So we can resolve it into two components. Do you agree that this component will be cos component and this component will be sine component beta? Yes or no? So cos component of the velocity should be equal to velocity of water to reach the opposite end. That is the condition that I have written here. To reach on opposite end, both the values of velocity should be equal. When you equate it, you are going to get the answer as option D, fourth option. Right. Many students were asking me to explain 10th question. Students, there is nothing to explain. This is a direct formula. If I write m v omega, this is a direct formula. You should have studied this in your earlier class. If you have not studied, you can just remember it better. You can just remember it, because when you substitute v as r times omega, right? So you are going to get a standard equation, mr omega square. So mv omega is a basic formula. There is nothing to explain over there. That brings us to 12th question, students. 12th question. A particle is projected such that the horizontal range and vertical height are same. Then the angle of projection is, students, according to this question, vertical height and horizontal range is same. Tell me, students, this formula on your right hand side, this formula, RHS, is formula to calculate what? Vertical height or range? What is it? It is a formula for vertical height. It is a formula for vertical height. And on the left hand side, this is the formula for range. Do you remember that the basic formula for range is u square sine 2 theta by g? So sine 2 theta can be written as 2 sine theta cos theta. Do you remember this? It can be written as 2 sine theta cos theta. Right. So when you write it in that format, and after cancellation, you are going to get tan theta as 4. You will get tan theta as 4. So the answer is going to be second option. That is tan inverse of 4. Second option, tan inverse of 4. That brings us to 13th question. At the top of the trajectory of a projectile, its direction of velocity and acceleration is. So students, at the top of the trajectory, see, this is the top of the trajectory. At the highest point, acceleration is because of gravity in downward direction and velocity is horizontal. So the angle between them is 90 degrees. Once again, a very easy answer, option C. So for 13th, the answer is option C. 14th question. An object is thrown along a direction inclined at an 45 degrees angle. What is the horizontal range of particle? Again, in today's lecture, we did that it is 4 times of maximum height. So R max is 4h. That is what we did today's lecture. So answer is fourth option, direct. 15th question. In projectile motion, if air resistance is neglected, then the horizontal motion will be, answer second option, constant velocity, because in horizontal direction, there will be no acceleration. Look, I have written that acceleration in x-axis is 0 in projectile. Acceleration along x-axis is 0 in projectile motion. We have written that over here, right? Is that clear? So we come to an end of 15th question, that is page 2. And Jay is saying 12th question. Jay, according to the question, range is given to equal as height according to the question. So this is the basic formula for height. And this is the basic formula for range. And after cancellation, you are going to get the answer written. Very easy. Students, I am very much, what we say, surprised that you are not able to recall the basic concepts of projectile motion. I am very much stunned, surprised. See, in 15th question also, the basics of projectile motion says that projectile motion is a freely falling motion. What does it say? Projectile motion is a freely falling motion. What does it mean? It means that the acceleration experienced at every point on the trajectory is in downward direction g. Acceleration in downward direction is g at every point. And acceleration along x-axis is 0. Now students, if acceleration along x-axis is 0, then velocity is constant. And hence the answer for this 15th question is second option, B. That is correct, Shriparna. Free fall along y-axis and uniform motion along x-axis. That is correct. But many students are not able to recall the basics. You should have revised. Now take a screenshot, beta. From question number 8, take a screenshot. Come on. Alex and Pratham, don't be impatient. I am going to reach to that question very soon and let you all know how to solve it. Please don't be impatient. Take a screenshot, beta. Om, weightage of 11 standard chapters in CET is 20% and 80% is of 12 standard. It is 20-80 ratio. So in short, from 50 questions, 10 questions will belong to 11 standard topic and the remaining 40 questions will belong to 12 standard. Okay, sufficient time given. I'm going to scroll down. Take a screenshot of these questions, solution. Take a screenshot, beta. Have you taken the screenshot? Right. That brings us to the end of second page. So we are going to start with the third page, that is 16th question onwards. Question number 16th. A ball is thrown at an angle of 30 degrees to the horizontal. It falls on the ground at a distance of 90 meters. If the ball is thrown with the same initial velocity at an angle of 60 degrees, it will fall on the ground at a distance of. Students, can we say that if horizontal distance is 90 meters, it means it is range given? And range 90 meters is given when angle is 30 degrees. Now the question is saying that what is the new range when the angle is 60 degrees? Do you remember that 30-60 are complementary angles, beta? 30-60 are complementary angles. And for complementary angles, the range is going to remain the same. That is the property. For complementary angles, the range will remain the same. So directly you can write the answer as option C. Directly you can write the answer as option C. Okay, that was easy. Alex, this is a simple question based on a property of range, that range is same for complementary angles. Complementary angles. That is a simple property, and that is what we have used. Range is same for theta and 90 minus theta. Right. That brings us to 17th question. See, students, I have drawn a beautiful diagram here. Even this diagram took a lot of time. So let's understand. A pipe lying on the ground shoots a stream of water upward at an angle of 60 degrees to the horizontal. The speed of the water is 20 meters per second. It will strike a wall 10 meters away at a height of. So clearly, students, there is a pipe given to us. So I have drawn a pipe here. And as you can see, there is water coming out from the pipe. The speed of the water given is 20 meters per second. And the angle is 60 degrees with the horizontal. This angle is 60 degrees with the horizontal. So of course, we can resolve it into two components, 20 cos 60 and 20 sin 60. The wall is placed at a distance of 10 meters. And we have to find the vertical height. We have to calculate the vertical height h. We have to calculate vertical height h. Okay. Well, in order to solve this question, once again, what we can do is we can make use of horizontal and vertical vectors. So first, I'm going to talk about horizontal vectors. In a horizontal direction, we can use the formula speed is equal to distance upon time. Speed is 20 cos 60, 20 cos 60. Distance is 10 meters, distance is 10 meters, and time is unknown. Time is unknown. So when you solve this, you will get the answer for time as 1 second. So students, we will say that water will take 1 second. Water will take 1 second to hit the wall. Water will take 1 second to hit the wall. Now you can use vertical concept as well. Vertical concept as well. And in vertical concept, you can say S is equal to ut plus half at square. Vertical velocity is 20 sin 60. 20 sin 60 is 20 root 3 by 2. And time taken is 1 second. And when you solve this, you will get the answer as 12.32 meters. 12.32 meters. This is what you are going to get. Answer is second option. Students, there is another method for this formula as well. As it is rightly pointed out by Ohm, there is another method, method 2. So let me discuss that method with you all. Method 2. And method 2 is by using the equation of trajectory. Do you remember which equation I'm talking about? Let me just copy paste it for you all. We're talking about this big equation. You can solve the question with this formula also. You can solve the question with this formula also, method 2. It doesn't matter which formula or which method you choose, answer should always be the same. Answer should always remain the same. No, we cannot use the formula of range because it is not necessary. See, in this question, like if this is your path, the wall can be placed here, or the wall can be placed here, or the wall can be placed here. We don't know where the wall is placed. Correct? We don't know where the wall is placed. So we cannot use anything related to range. We cannot use anything related to range. Right. We understood that. That brings us to the 18th question, students. It brings us to the 18th question. A particle having a mass 0.5 kilogram is projected under gravity with a speed of 98 meters per second at an angle of 30 degrees. The magnitude of change in momentum after 10 seconds is. So as you can see over here, 98 meters per second, 30 degrees, we have resolved it into two components. Cos and sine. And we have to find the change in momentum after 10 seconds. So students, along this trajectory, we first have to find that where will the particle be after 10 seconds, correct? Along this entire trajectory, we will first have to find that after 10 seconds, where is the particle? ऐसा भी हो सकता है that 10 seconds बाद or the particle is here or the particle is here or anywhere else. So first what we have to do is we have to find location of the particle after 10 seconds. So we have used the formula for time of flight, and when we substitute the formula for time of flight, we are getting the answer as 10 seconds itself. It means that complete after 10 seconds, particle will be at point Q. Complete after 10 seconds, particle will be at point Q. Now, what if it was not equal to time of flight? What if the time was not equal to time of flight? Then what you have to do is you have to use these two concepts. Speed is distance upon time and ut plus half at square to determine the position of the particle. Okay, then you have to use those two concepts to determine the position of the particle. Are you getting it? Right. Now change in momentum is final momentum minus initial momentum. Momentum, we can take common mass, and then we are writing final velocity minus initial velocity. Students, this part is final velocity Vf. And this part is initial velocity Vi. This part is initial velocity Vi. Now can you see this is cos 30 I cap minus sin 30 j cap, and this is cos 30 I cap and plus sin 30 j cap. That is exactly what we have substituted there. Now you solve, open the brackets, you will get the answer as second option. And that brings us to 19th question. Right, let's have a look at 19th question. An aircraft is moving with a uniform velocity 150 meters per second. If all the forces are balanced, then it will keep moving with the same velocity, second option. Students, balanced forces means acceleration is zero. Means it's a uniform motion. V is constant. That brings us to 20th question, 20. A force vector is given to us, is producing a displacement vector. If the work done is 14 joules, what is A? Do you remember work is force times displacement? Yes or no? Work is force dot displacement. Now look, I have written the coordinates. Okay, I have written the vectors in terms of coordinates. So coordinates of force and displacement I have written. And when I am solving that, I am getting the answer as 5. That is option C. Okay. Vedant, we can not use the formula ma into t for the 18th question. You should not use the formula ma into t because we are dealing with vectors. Anyways, let us talk about 21st question. 21st question. A block of mass m moving on a frictionless surface at speed v collides elastically with a block of same mass initially at rest. Now the first block moves at an angle theta with its initial direction and has a speed v. The speed of the block, second block after collision. So students, I have done a simple representation. Where before and after collision situations are shown. And I started with momentum conservation. But when I take momentum conservation, the options are not matching. So do you remember that during elastic collision, during elastic collision, even kinetic energy is conserved? So then I use kinetic energy conservation. Initial kinetic energy is equal to final kinetic energy. When I substitute the values, half m, initial velocity was v square. So half m v square. Finally, the velocity was v1 square and v2 square. So it is half m1 v1 square and half m v2 square. Cancelling the common terms, we get a relation, and that relation is v square is equal to v1 square plus v2 square. This relation we are getting. And when you rearrange, you will get the answer as option C. You will get the answer as option C for 21st. So students, when I was solving this question, I first used momentum conservation. But as you see, that answer is not matching with the options. So I used energy conservation, kinetic energy, because it is elastic collision. That brings us to 22nd question. A block of mass m is being pulled along a smooth surface by a rope of mass small m. What will be the acceleration of the block? Students, do you remember that acceleration is force upon total mass? Yes or no? Acceleration is given by force upon total mass. So it will be F upon m plus m. Answer is option C. Answer is option C. And that brings us to 23rd question. A rod L is acted upon by a couple as shown in the figure. The moment of the couple is tau. The magnitude of each forces. So students, torque, that is couple, is given by the formula force into perpendicular distance. Now look, with red color, I have shown force over here. In the diagram, this is the direction in which force is acting. Then are you able to see that this blue color is perpendicular to F vector? Yes or no? And how much length is this, beta? How much length is this? So that perpendicular distance is L cos 60. That perpendicular distance is L cos 60. So when you solve this, you will get the answer to the question as option 4th. You will get the answer to the question as option 4th. Right. Okay, now what are you guys saying? In question 8, I applied v is equal to u plus 18 vertical motion, found final velocity in y. Then I am getting a different answer in question 18. Because that is just the vertical value. You have not considered horizontal component of the velocity, and that is the reason you are getting different answer. So what you found out? V, that V is just vertical component. That V is just vertical component. Right. Now, students, you can start taking a screenshot from question 16. From 16th question onwards, you can start taking a screenshot. Come on, students. Start a screenshot from your. Daksh, you might not have used vectors correctly, but I don't understand that why do you want to? Why do you want to use vectors when you can, with common sense, say that since time of ascent is equal to time of descent, so velocities will just be opposite. Why can't you use that? I hope you have taken a screenshot. Now take a screenshot of 17th question separately. 17th question. Seventeenth question. Now take a screenshot of 18th and 19th question. Anushka, in question number 18, they are asking us to calculate change in momentum after 10 seconds. So for change in momentum, what do you require? You require two things. For change in momentum, you require two things: initial position and final position. So first, what you have to do is you have to find, with a little research, that after 10 seconds, where will the particle lie? After 10 seconds, where will the particle lie? We found out that the particle lies exactly at the end of trajectory. And then what we have done is simple calculation of change in momentum, final velocity minus initial velocity, with vector concept. Is that clear, Anushka? Right. After having copied 19th question, you can now start copying, or sorry, taking a screenshot of this much part. Take a screenshot from your. Take a screenshot from your. Students, have you all taken a screenshot? Students, there is no such thing called as chapter-wise weightage. This is competitive exam, that to CET. So weightage will change every year. It just depends on the examiner. So there is no point in giving you all any kind of weightage. Okay, take a screenshot till here, beta. Take a screenshot of this part. Come on. Students, I am going to request you again. Do not ask me general questions right now. I have made this very clear that right now you focus on what is going on. Why do you want to deviate from the topic? Are you not finding that once you ask these questions, this list of questions just continues and there is a break in the thought process, thinking process? Don't do this. Whatever queries you have, you ask towards the end. I'm not denying. I'll answer them, but not right now, towards the end of the lecture. Right. Come to 24th question. Come to, I guess in whatever time we have, we can solve 24th question in a minute. Let's read it. Come on, let's read it. 24th question. The question says, kinetic energy with time is shown as a straight line, then the force acting is what? So students, we can say that kinetic energy is proportional to time. So can we write kinetic energy half mv square is equal to kt? K is constant of proportionality. So from here we can get velocity is root of 2k t by m. So just remember that velocity is proportional to root t. We will borrow it in the further use. Just remember this relation. We are going to use it further. Achha, once we got velocity in terms of time, we want acceleration. So acceleration is dv by dt. We found out derivative. We substitute that in MA formula. And in MA formula, after rearrangement, we are getting F is inversely proportional to root T. And if you recall, just now I said that root T is nothing but V. So we get F is inversely proportional to V. Answer is option C.